In graph 9.8, we connected the demand functions that emerge from Cobb-Douglas utility functions with exponents of 0.75 and 0.25 to income demand curves. We'll now do the same for own price demand curves using the same utility function. In the text we use the utility function x1 to the alpha, x2 to the 1 minus alpha to derive the demand functions that tell us for each good how much the consumer will consume as a function of the consumer's economic circumstances, his income and the prices. These demand functions are then given in equation 9.4 of the text. When we graph own price demand curves, we're really graphing slices of the inverses of these functions. For instance, we can take the demand function for good 1, which is x1 equal to alpha I divided by p1, and solve it for p1 to get p1 is equal to alpha I divided by x1. That's the inverse, solved for p1, and the equations of these inverse demand functions are given in equation 9.11 of the text. The slopes of these demand curves are then simply the partial derivatives of the inverse demand functions with respect to the x's. These are given here and also presented in the text as equation 9.13. Our alpha is 0.75, and we can pick an income, say an income of 50, and then trace out the demand curve using this inverse demand function. The slope of this demand curve is given by our partial derivative, minus alpha I divided by x1 squared. With alpha equal to 0.75 and I assumed to be 50, that gives us an equation of minus 37.5 divided by x1 squared. For low levels of x1, this implies a small denominator and thus a large number in absolute value. In other words, the slope starts out very steep. But then, as x1 increases and we move to the right in our graph, the denominator increases, and it increases fast because x1 is squared. Thus, as we move to the right in the graph, the absolute value of the slope falls dramatically, and thus the slope becomes shallower quickly. As we increase income, we're increasing the numerator in the inverse demand function and are thus shifting the demand curve out. This also changes the numerator in our slope term from 37.5 to 75. Thus, for any given x1 value, the slope will now be steeper than it was before. And if we increase income even further, it will again shift the demand curve. This will in general be true for demand curves. As we change income, we're switching to a different slice of the inverse demand function, which shows up as a shift in the demand curve. If the underlying good is a normal good, then an increase in income will cause an increase in consumption at any given price, and therefore each point on the original demand curve will shift to the right. If, on the other hand, the underlying good were an inferior good, then an increase in income would cause a leftward shift in the demand curve, because at any given price, the increase in income would lead to a decrease in consumption. The only time when a change in income will not cause a shift in the demand curve is if the underlying good is quasi-linear, right between normal and inferior goods. We can of course also illustrate the own price demand curve for x2. Since x2 has a lower weight in the utility function, a weight of only 0.25, we'll get a different shape for each of the demand curves. If we assume an income of 50, for example, we get this green demand curve for good x2. You can again see the slope term in the partial derivative, which in our case now is minus 12.5 divided by x2 squared. It has a smaller numerator than it did for x1, because 1 minus alpha is 0.25, whereas alpha was 0.75. Raising income again increases the numerator of the inverse demand function, and therefore shifts the demand curve to the right. The rightward or upward shift in the demand curves as income increases happens in both goods, because Cobb-Douglas tastes represent tastes for goods that are normal goods. Thus both x1 and x2 are normal goods in this case. Demand functions tell us for any income and any set of prices how much the consumer will consume of a good. In other words, demand functions tell us how much of a consumer will consume given any particular economic circumstances that you might plug in. Demand curves, on the other hand, keep most of the economic environment the consumer operates in fixed. Own price demand curves hold fixed income and the prices of other goods, and are therefore simply inverse slices of the demand function. As the other aspects of the economic environment change, as incomes or other prices change, demand curves therefore typically shift because we shift to other slices of the inverse demand function.